Normal forms. Already in the last class we have seen normalization. If you did not see, please watch that video so that you can understand the normal forms. 1NF, 2NF, 3NF, BCNF, 4NF. So here first we will see first normal form. A relation is said to be 1NF if it doesn't contain atomic values. That is, an attribute of a table cannot hold multiple values. For example, atomic means single. Each attribute must consist a single value. Then you can say that that is atomic. If the table is in atomic, then you can say that it is in 1NF. For example, if you observe this table, rule number, name and course. Rule number 1, Ravi is joined for two courses like C and C++. So Raju joined for Java and C. Sita joined for only DBMS. So here Ravi is holding two values, C and C++. This is not atomic. Now you need to convert this table into one normal form. Okay, first normal form. If you make this into a first normal form, you need to mention the same attributes, rule number, name, course. Rule number 1, Ravi joined for C, and also rule number 1, Ravi joined for C++. Rule number 2, Raju joined for Java and also C. 3, Sita joined for DBMS. Now this table is in 1NF. This table is not in 1NF. Next we will see 2NF. 2NF is nothing but a second normal form. A relation is said to be 2NF if it is in 1NF and also no partial dependency. What do you mean by partial dependency? Means every non-key attribute fully depends on the primary key of a relation, which is nothing but a prime key attribute. Part of the prime key attribute determines non-key attribute. Then you can say that that is partial dependency. We will see with example. So here terminologies related to normalization you should know before that, partial dependency, functional dependency. If you know that, then you can easily understand what is 2NF. Functional dependency is nothing but a, for example, in attribute X is determines Y. Attribute X is nothing but a key attribute. Q attribute determines a non-key attribute. Then you can say that that is functional dependency, or you can call it as a dependency also. For example, what do you mean by key attribute? If any row uniquely identifies, then you can say that that is a key attribute. Non-key attribute means which may have duplication of data, uniquely cannot identify. For example, by seeing the table you can come to know that rule number is obviously key attribute. Why? Because every student has its own unique values. So here rule number is a key attribute and name is a non-key attribute, and also marks are non-key attribute. Why? Because marks may be repeat and name also may repeat. So here rule number alone can identify name of the student. Rule number alone can identify marks of a student. Rule number alone can identify name and marks of a student. So here rule number is a key attribute and name and marks are the non-key attribute. Rule number determines name and marks, or you can also call it as a name and marks of a student can be identified by using the rule number. So here name and marks are fully depending on the rule number. That is nothing but a full dependent or functional dependency. Okay, now we will see partial dependency. Partial dependency means non-key attributes depends on the part of the primary key. So whenever the non-key attribute depending on the part of the primary key, then you can say that that is a partial dependency. So here we will see with one example. If you consider this table, student table I considered, if you observe here, rule number 1 is joined for some courses like 5, 10, 20, which is nothing but a C, C++ and Java. Rule number 2 is joined for multiple courses, and rule number 3 joined for some single course. So here some student in some institute, he joined for C and C++ and Java. So here, alone with the roll number, you cannot identify what is the subject name of the student. So here, alone with the roll number, you cannot identify the subject name. Why? Because roll number 1 is having subject name C and also C++ and also Java. Which subject he joined? You cannot say. With rule number 1, he is having multiple courses. With this rule number is not a key attribute here. Alone rule number is not a key attribute here. If you observe, rule number and subject ID, with rule number and subject ID, we can tell the subject name of a student. Rule number 1, subject ID 5. Rule number 1, subject ID 5 means he joined for the course C. He joined for the course C. Rule number 1, subject ID 10 means he joined for the course C++. Rule number 1, subject ID 20 means he joined for the course Java. Like that you can tell. So here, alone rule number cannot identify the subject name here. Along with the rule number and subject ID, we can mention what is the subject name. Now, rule number and subject ID both are the key attributes. And subject name is nothing but here non-key attributes here. So here, rule number and subject ID both are key attributes. Both. Okay, alone with the rule number, you cannot identify subject name of the student. Why? Because Amit is joined for C and C++ and Java. Okay, so here rule number and with the subject ID combination, you can tell what is his subject name. So here rule number and subject ID both are key attributes, and here with the along with the roll number and subject ID, you can identify the marks of your student also. So here by using rule number and subject ID, you can find the subject name, and also along with the roll number and subject ID, you can also identify the marks of your student. Only alone rule number cannot identify the marks. Why? Because rule number 1 is having marks 80, 50, 90. Okay. So here, which marks you will tell? 80 or 50 or 90. So the rule number alone cannot identify the marks of a student. But with rule number and subject ID, you can identify the marks. Yes, rule number 1, subject ID 5 means he got the marks 80. Like that you can tell. So here, rule number and subject ID, you can tell the marks. So here, subject name is completely depending on the rule number and subject ID here. But here, these rule number and subject ID are the keys, prime attributes. Prime attributes determining the non-prime attribute here. And if you observe here, subject ID is determining the subject name here. Subject ID 5 means subject name 10. Sorry, C. Subject ID 10 means C++. 10 means C++. 5 means C. 20 means Java. So here, subject ID is determining the subject name here. So here, subject name is non-key attribute. This non-key attribute is depending on the part of the primary key. Okay, subject ID is nothing but a part of the prime attribute. Okay, so here subject name is depending on the part of the prime attribute. Okay, so that's why this is nothing but a partial dependency. Partial dependencies are not allowed in the 2NF. If you observe here, by seeing the roll number, you can identify the student name. 1 means Ravi, 2 means Amit, 3 means John. Okay, so whenever the 1 appears, it is showing Ravi only. Okay, whenever the 2 appears, it is showing Amit only. So here, alone with rule number, you can identify student name. But rule number is nothing but a what? Part of the primary key. Okay, so here non-key attributes. Student name is nothing but a non-key attribute. Non-key attribute depending on the part of the primary key. Okay, that is nothing but a partial dependency. That type of partial dependencies are not allowed in the 2NF. So now this table is not in 2NF. To make it into 2NF, you need to decompose the table like this. Roll number, subject ID, marks. Along with the roll number and subject ID, you can identify the marks. Along with the roll number, you can identify the student names, and along with the roll number, subject name, and who is the teacher for that particular subject, you can identify. So these are the tables you need to make to convert into a 2NF. Now these tables are in 2NF. Thank you. Please subscribe to my channel. If any doubts, please comment.